Hello everyone. Our lesson today is lesson 1 in unit 1, which is organizing data in matrices. What's the meaning of matrices? If we have a matrix, first we denoted by this matrix by capital letter. Any capital letter like A. Okay. This matrix consists of number of elements, and these elements we write it in rows and columns like 3, 2, 1, 7, 5, 0. Okay. Here we have two rows. Here the first row, second row, and we have 1, 2, 3 columns. So any matrix denoted by a capital letter and consists of number of elements in rows and columns. Okay. We want to know also the order of this matrix. What's the meaning of the order of any matrix? To get the order of any matrix, determine how many rows multiplied by how many columns. In our matrix here, we have two rows. Here we have 1 times 2. So 2 multiplied by the number of columns. Here we have how many columns? 1, 2, 3. So the order of matrix A is 2 multiplied by 3. Okay? For example, if B equals 3, 2, 1, 0, 1, 5, 2, 0, 1. Okay, we want to get the order of the matrix B. As we said, the order of the matrix is the number of rows multiplied by the number of columns. Here we have how many rows? 1, 2, 3. 3 multiplied by how many columns? 1, 2, 3. So this matrix is of order 3 multiplied by 3. Another one. X equals 3, 4, 2, 5, 1, 0. The order of the matrix X is determine how many rows? 1, 2, 3. 3 multiplied by. Here how many columns? 1, 2. So the order here is 3 multiplied by 2. It means we have 3 rows and 2 columns. Okay? In general, any matrix, we have A equals A11. What's the meaning of A11? The location of this element is in the first row and first column. Okay, here A12. This element is in the first row and second column. A13, this element in the first row and the third column, and so on. Okay? And also we have the main diagonal or the principal diagonal. What is the main diagonal or the principal diagonal? Here we have the elements which is A11, A22, A33. This is called the main diagonal. Okay, let's take some examples. If A is 3, 2, 1, 5, 7, 0, write the order of A. As we said, the order of any matrix is the number of rows multiplied by the number of columns. Here, how many rows? 1, 2. So 2 multiplied by how many columns? 1, 2, 3. So here A is a matrix of order 2 multiplied by 3. Okay. State A21. What's the meaning of A21? It means the element in the second row and first column. Second row here, first column, which is 5. Okay. And A12. A12, it means the element in the first row and second column. Here we have the first row, second column, which is 2. Okay. We have here some special matrices or the type of matrices. First, the row matrix. From its name, the row matrix, it is a matrix consists of only one row and any number of columns. So here we have only one row and any number of columns. Number of columns like first column or second column or third column and so on. Okay, so here we have only one row. Okay, let's get the order of this matrix. As we said, one row, 1 multiplied by how many columns? 1, 2, 3. So the order here is 1 multiplied by 3. Okay, the second one is the column matrices. Also from its name, it's a matrix consists of only one column and any number of rows. Okay, let's get the order of this matrix. Here we have first start from the number of rows. Don't forget. Here the number of rows 1, 2, 3. So 3 multiplied by the number of columns, which is one column. Okay, what did you notice here? In any matrix, don't exchange the number of rows and the number of columns because it will be different. Okay, here this matrix not equal this matrix. Okay, the third one is the square matrix. What's the meaning of the square matrix? It's a matrix which is the number of rows equal the number of columns. Like here we have 2 rows and 2 columns. So the order here will be 2 times 2, which is we have 2 rows and 2 columns. Okay, or here we have here 3 rows and 3 columns. So the square matrix is a matrix which is the number of rows equals the number of columns. Okay, the zero matrix. From its name, it's a matrix. All elements are 0 and we denoted by 0 capital. And this matrix consists of any number of row and any number of columns. Here we have 2 times 2 and here we have 3 times 3. Okay, the diagonal matrix. What's the meaning of the diagonal matrix? In this matrix, all elements are 0 except the elements of the main diagonal. And we said before, what's the main diagonal? Here we have the main diagonal. Okay, or we have at least one of the element of the main diagonal not equal to 0. Like here, we have only one element not equal to 0. Okay, finally, the unit matrix, and we denote it by I, or identically matrix. Here we have the main diagonals is number 1. Like here we have the main diagonals, here is 1 and here is 1. Okay, another title, the equality of two matrices. Two matrices are said to be equal if and only if we have here two conditions. The two matrices have the same order and their corresponding elements are equal. For example, here we have this matrix, this order of this matrix is 2 times 2. And here also 2 times 2. Okay, and their corresponding elements are equal. What's the meaning of corresponding elements? We get here x equals 3, y equals 1, z equals 2, L equals 5. So we get here x equals 3, y equals 1, z equals 2, finally L equals 5. We have another example. If 2x minus 1, 3, 5, 2y plus 7 equals 7, 3, 5, 8. Here we have two matrices have the same order. Here we have 2 times 2 and here 2 times 2. So the corresponding elements are equal. Since the two matrices are equal. So we get the corresponding elements are equal. So 2x minus 1 equals 7. It's an equation of first degree. First, move negative 1 in the other side by opposite sign, which is positive 1. So 2x equals 7 plus 1, which is 8. So 2x equals 8. We want to get the value of x. Move 2 in the other side by opposite operation, which is divided. So 8 divided 2. So we have x equals 4. Okay. And the corresponding 2y plus 7 equals 8. So we have also another equation, 2y plus 7 equals 8. First, move positive 7 in the other by negative 7. So 2y equals 8 minus 7, which is 1. Here we have 2y equals 1. Move 2 in the other by divided. So the value of y equals half. Okay, another example. Find the value of A, B, C, and D. Here we have two matrices have the same order, so their corresponding elements are equal. Since the two matrices are equal. So we get their corresponding elements are equal. So here we have 3 equals A minus 2, or A minus 2 equals 3. To get the value of 2, move negative 2 in the other side by opposite sign, which is positive 2. 3 plus 2. So A here equals 5. Okay. And also we have 2b plus 1 equals negative 5. Another equation. Move positive 1 in the other by negative 1. 2b equals negative 5 minus 1, which is negative 6. So 2b equals negative 6. So the value of b, negative 6 divided 2, which is negative 3. We get the value of b. Okay. And here we have a minus 3 equals c. Okay. Here we have two unknown. No, we get already the value of a, which is 5. So substitution here with a equals 5. So we get 5 minus 3 equals c. So we get c equals 2. Okay, finally, we want to get the value of d. Here we have 3d minus 2 equals 16. Also another equation. 3d minus 2 equals 16. Move 2 in the other by positive. So we get 3d equals 16 plus 2, which is 18. 3d equals 18. Move 3 in the other by divided. 18 divided 3, which is 6. So the value of d equals 6. So we get the value of a, b, c, and d. Okay, another title we have multiplying by a real number. Okay. If we have a matrix A, which is 6, negative 2, 3, 2, 4, 0, this matrix is of order 2 multiplied by 3, 2 rows and 3 columns. Okay, we want to get 2A. What's the meaning of 2A? 2 multiplied by the matrix A. Okay. So 2, we want to get 2 multiplied by the matrix. So 2 multiplied by every element in this matrix. So first 2 multiplied 6 equals 12. 2 multiplied negative 2, it will be negative 4. 2 multiplied 3, it will be 6. 2 multiplied 2, 4. 2 multiplied 4, 8. 2 multiplied 0 equals 0. So here we have 2a. Okay. In any matrix, it's possible to take a common factor among the elements of the matrix. Here in this matrix, we get the common factor 2. Okay? Another title, Matrix Transpose. And we denote it by T, like here. Here we have A 321502. AT, which is transpose. Okay? We change the first row to be the first column. Okay. Here we have the first row, which is 321. We change it to get the first column. 3, 2, 1. Okay. And also we change the second row to be the second column. Here we have 5, 0, -2. And this is transpose. Okay. A transpose, it will be change the first row to be the first column and second row to be second column and so on. Okay. Here in A, in the matrix A, the order of matrix A is 2 times 3. And the order of A transpose is 3 times 2. So the order here will be changed. Okay. Okay. What about A transpose? Transpose. So make this matrix transpose. As we said, make the first row as a column. So 3, 5, it will be column. 3, 5. Second row, it will be column. 2, 0. Third row, it will be column. 1, -2. What did you notice? Here, A transpose, all transpose, it will be the original matrix. So here we have a rule. A transpose, all transpose equal the same matrix. Okay? And this is very important. Okay. Another title, Symmetric and Skew Symmetric Matrix. Okay. First, if we have matrix A 0, 1, 3, 1, 0, 2, 3, 2, 0. Okay. We want to get A transpose. As we said, change the first row to be the first column. So here 0, 1, 3, it will be first row. 1, 0, 1, 3. Second row, it will be second column. 1, 0, 2. Here 3, 2, 0, it will be third column. 3, 2, 0. Okay. What did you notice? Here we have A transpose equal A. So if we get A equals its transpose, then A is called matrix, symmetric matrix. Then A is called symmetric matrix. Okay, let's take another one. If X equals 0, 1, 2, -1, 0, -3, -2, 3, 0. We want to get X transpose. As we said, first row, it will be first column. So here we have 0, 1, 2, -1, 0, -3, -2, 3, 0. Okay. What about to multiply it by -1? Negative X transpose. So multiply it by every element here by -1. 0 by -1, it will be 0. -1 by -1, it will be 1. -1 by -2, 2. Here -1, 0. -3, -2, 3, 0. What did you notice? X here 0, 1, 2, -1, 0, -3, negative 2 3 0 equals negative x transpose. So if we get x equals negative x transpose, so X is called skew symmetric matrix. Okay, so we know two definition: symmetric matrix if A equals A transpose, skew symmetric matrix if A equals negative A transpose. Okay, we have a remark. If matrix A equals this, A is symmetric matrix, then here, as we said, the main diagonal ABC, the main diagonal here is like a mirror. Okay, so we said here D equals D. Here is this element is in first row and second column, equals this element is in second row and first column. So we said A equals 1 2, sorry, A1 2 equals A2 1, which is D. Okay, and also here this element in first row and third column equals X exchange E here in third column, third row and first column. So here equals E. And finally here we have F, third row and sorry, second row and third column, and F here third row and second column. Okay, so if A is asymmetric, we have here A1 2 equals A2 1, A1 3 equals A3 1, A2 3 equals A3 2. Okay, and if the matrix is a skew matrix, don't forget to write negative. So here we have here the main diagonal. So A21 equals negative A12, A31 is negative A13, A32 is negative A23. Let's take some examples. If A is a symmetric matrix, here, find the value of X and Y. Here we have two methods. Symmetric matrix, so get A transpose and let A equals A transpose. Two matrices are equal and their corresponding elements are equal to get the unknown. Okay, or determine the main diagonal, and as we said, here we have 2x equals negative 4. Here we have 2x plus y equals 8 and 6 equals 6. Okay, and this is much easy. Okay, so first, since A is a symmetric matrix, so we have here, as we said, 2x equals negative 4. It's an equation. Move 2 in the other by divided, negative 4 divided 2, so x equals negative 2. Okay, and also x plus 2y equals 8. Here, this element in third row and first column. Here we have 3 1, which is equal A3 1 3 1 3 first row and third column, which is A 8. Okay, so we get also x plus 2y equals 8. Here we have two unknown. No, we already know the value of x, which is negative 2 by substitution. So we get negative 2 plus 2y equals 8. Move negative 2 in the other by positive. We get 2y equals 8 plus 2, which is 10. Move 2 in the other by divided. So the value of y equals 5. Okay, another example. We have here B is a skew matrix. Find x, y, and z. Okay, as we said here, the main diagonal skew matrix, which is here we have B 1, 2 equals B 2, 1. Okay, and so on. B 1, 3 equals B 3, 1. And also here we have B 2, 3 equals B 3, 2. Okay, but by negative. Why? Because here skew matrix. Okay, first, since B is skew symmetric matrix, we get z plus x, sorry, z plus 3 equals negative x. Here we have two unknowns, so let it number 1. Okay, and also we have 3y minus 6 equals negative 7. Equals negative 7. Also we have here two unknown, let it number 2. Okay, finally here we have negative 2z equals negative 6. Okay, here we have one unknown, so it's easy to get the value of z. Move negative 2 in the other by divided, so the value of z equals 3. Okay, by substitution in 1 to get the value of x. So 3 plus 3 equals negative x. So negative x equals 6 divided by negative 1. So x equals negative 6. Okay. Sorry, here z plus 3 equals 3x. يبقى negative 3x. Okay. Here negative 3x. So negative 3x equals 6 divided by negative 3, which is negative 2. Okay. Sorry, negative 2. Okay. Substitution in equation number 2 to get the value of y. We have here 3y minus x equals negative 7. So 3y negative 2, it will be positive 2 equals negative 7. Move positive 2 in the other by negative. So 3y equals negative 7 minus 2, which is negative 9. 3y equals negative 9 divided by 3. So y equals negative 9 divided by 3, which is negative 3. Okay? Thank you.